So in this video, I'm going to show a few examples of integrals with partial fractions, and in these examples we'll have linear factors only. So I'm going to go through these three examples. So I think like the thing with doing partial fractions is it's very helpful, of course, if you're given integrals like this, to first factor them fully. So I just want to show you, so these are all linear factors, and so this is what I'm going to go through in this video, so you can pause if you want to read it over. Otherwise, I'll just jump right into it. Okay, so starting with A, so this is what I consider to be kind of the most straightforward, I guess, type of partial fraction, in that we have three unique linear factors. Okay, so the setup that you want to use, I really like doing something that makes a lot of sense versus like thinking of shortcuts or, I don't know, different algorithms of how to do this. So the idea behind this is I'm going to take the original fraction and I want to break it into three pieces. So the three pieces are going to pick up each one of these linear factors, like so. And then what I do is I multiply this denominator against all three fractions. And so when I do that, so for instance, when I multiply this denominator against this fraction, right? So I'm kind of just like multiplying it over to the other side. So when I multiply this over to this side, what am I left with? Well, the x's, right? The x's will drop out. So I'm left with, so still 1 on this side, right? I got rid of the denominator, but the 1 is still on top. And then this is a plus 2, a minus 1. And then when I multiply this times the second fraction, so the x plus 2 is going to cancel out. So I've got bx times x minus 1. And then I will multiply this by the third fraction. And so that's going to be x times x plus 2 is what's left over. Now, before I go any further, I just want you to appreciate that I've literally multiplied this denominator over to the other side. But this 1 is still here, right? So the top part of the fraction is still intact. Okay, so from here, let's clear some space. Okay, so I'm going to leave the a, b, and c on the outside, but I want to multiply all the x factors together. So this will be x squared plus x minus 2. This will be plus b x squared minus x. And then this will be c x squared plus 2x. Okay, so here's the deal. We're trying to set up a system. So what I want to do is now I want to go through and I want to collect by x variables. So what I mean is, okay, so I've got these three x squareds. So I've still got this part as 1. Okay, so if I wanted to factor out the x squared, so what would that leave me with? So I'd have x squared times a, so that's going to be a, x squared times b, and then x squared times c. Okay, so just go with me here for a second if you're a little unsure about this. So that's how all of the x squared terms kind of multiply against the a, b, and c. So next we're going to move on to the x terms. So I've got an x here, I've got an x here, I've got an x here. So I'm going to set the x here, and now, so I've got x times a, so that's just going to leave me with 1a. Now look at what happens for this next one. I've got negative x times b, so that leaves me with negative b, right? And then what's the last one? 2x times c is going to leave me with positive 2c. And then the last term that I'm working on are just the constants. So I've really just got that negative 2. Now I just want to give that a placeholder, so I'm going to call that x to the 0, and then this will be negative 2a, okay? Because there's only this one constant here, and I'm bouncing it off of the a, so that just leaves me with that. And you always just put in a placeholder of x to the 0 for your constants. Okay, so now the next part of this is I want to set up a system of equations. And when I do that, I'm going to be using this 1 right here. So this 1 is the coefficients for the constants, okay? So let me just show you how this gets set up. So I have for x squared, okay, so for my x squared terms, what I'm going to do is I've got this a, b, and c, a, b, and c. So I'm going to set that equal to whatever the coefficient for the x squared term is on this side. And there is no x squared on this side, right? So that's going to be a 0. Next, we're going to move on to the x's. So that was a minus b plus 2c. Okay, so now this is what do I want to set this equal to? Well, again, I refer to this side. There is no x on this side, right? So once again, this is going to equal 0. And then finally, for my constant term, so x to the 0, so that's just negative 2a. So this is where I've got something that I can actually set this equal to. Negative 2a, the only constant on the left side is 1. So that's what I'm going to set this equal to. And now I've got this system, so now I want to go through and solve it. So let's make some space. Okay, so this is now effectively a system, and so I'm just going to go through and solve for each one of these letters. So a is obviously going to be negative 1/2. Okay, so now I'm going to plug in this negative 1/2 into these equations up here. So let's see, I'm going to have negative 1/2 plus b plus c equals 0, and negative 1/2 minus b plus 2c equals 0. Now, you might recall from the good old days of algebra, the elimination method, where I just add these two equations down. So this will become negative 1. The b's drop out, and then I'm left with plus 3c equals 0. And so from here, I can have that 3c equals 1. So that's going to tell me then that c equals 1/3. Okay, and then I just have to finish solving for b. So let's see, I'll use the first equation. So we've got negative 1/2 plus b plus 1/3. This needs to equal 0. So obviously I've got to get a common denominator, so let's call this negative 3/6 plus b plus 2/6 equals 0. So this gives me negative 1/6 plus b equals 0, therefore b equals positive 1/6. And so just to recap, so I have a, b, and c. So now I can actually set up my integral. So let's maybe go back to the original problem. So this was the setup that I had, and now I can set up this integral with my numbers. Oops. My numbers. So I've got negative 1/2x plus 1/6 times x plus 2 plus 1/3 x minus 1. So here's what I need to integrate. And then integrating this is nice and straightforward because it's all just natural log. So I've got negative 1/2 natural log of x plus 1/6 natural log of x plus 2, and then 1/3 natural log of x minus 1 plus c. Okay, so now let's contrast that example to b here, where I have a linear factor that's going to repeat. So how do we set that up? So for this type of example, so I'm going to once again set up the same just initial fraction. The setup in this case is that, so I've got the a over x minus 1, b over x plus 1, and then c over x plus 1 squared. So you just show how these terms are like repeating. Okay, so as far as like solving this, it's kind of the same idea. So I'm going to take this denominator times each one of these fractions, okay? So if you're playing along at home here, I strongly recommend that you just give this a try on your own just to make sure that you're understanding this, and hit play when you're ready. So let's see. So I've got x squared, so I leave the numerator. So if I multiply this times this fraction, I am just left with a times x plus 1 squared. Then the second fraction, when I multiply this denominator times the second fraction, I'm left with x minus 1, x plus 1. And then for the final fraction times this denominator, so the x plus 1 squares drop out, so I'm just left with x minus 1. Okay, so once again, let's make a little space. Okay, so first things first, we've got to multiply everything out. So this will be x squared plus 2x plus 1. This will be x squared minus 1. And then this I don't have anything to multiply out. Okay, so now, remember that I'm going to leave the x squared here. So I want to first factor out all my x squareds. So I've got an x squared there and there. So if I factor out the x squareds, so now I go through and I multiply. So x squared times a is just going to leave me with a. And then x squared times b is just going to leave me with b. Okay. Next, we're going to move on to the x's. So I've only got x's there and there in this case. So I'm going to factor out the x. So I've got 2x times a. So if I factor out the x, that's just going to leave me with 2a, right? And then I've got this x times c, so that's just going to leave me with c. Okay. And then finally, I've got the constant term, so I'm going to put x0 there. So I've got a constant here, here, and here. And so I've got 1 times a, so that's just a, minus 1 times b, so that's minus b, and then minus 1 times c is minus c. So minus times that, minus times that. Okay, so now I can set up my system. And so in this case, so once again, I'm going to set up for x squared, x, and x to the 0. Okay, so in this case now, once again, I'm using the left side to kind of set up my equation. So for my x squareds, I've got this a plus b, and then I reference the left side. What's the coefficient on the left side for x squared? It is 1, so it's going to be a plus b equals 1. Then for the x's, I've got 2a plus c, so I've got 2a plus c. And you'll notice I have no x now on this side, so that's going to have that's going to all equal 0. And then the same thing goes for the constants. So a minus b minus c. There's no constant on the left side, so I just set that equal to 0. And so here's the system now that I have to solve. So let's make some space. Okay, so this time to solve my system, I would actually strongly recommend that you try to solve the system, by the way, if you're playing along at home here. Best way to learn math is to just get your hands dirty with it. Worst that happens is you get stuck and then you got to watch the explanation, but you'll learn more if you actually try. So I strongly recommend you pause here and then hit play when you're stuck or when you think you've got it. Okay, so in this case, what I want to do is I want to combine the first equation and the last equation, because when I use elimination, this is going to give me 2a, the b's will drop out, minus c equals 1. So now I've taken, I've taken these two equations, and now I've gotten this down to just in terms of a and c, so now I can match that up with this equation here. So now I'm going to have the second equation like so. And once again, I can use elimination here, right? So I can go ahead and eliminate. I'm running out of space, but this will come out to 4a equals 1. So I get 4a equals 1, which would imply that a is going to be 1/4. So now from here, I can just fill everything else in. So let's see. I will plug a into the first equation. We'll start there. So I'll have 1/4 plus b equals 1. So therefore, b is going to equal 3/4. And then I'll plug in 2 times 1/4 plus c equals 0. So it's going to be 1/2 plus c equals 0. So c is going to equal -1/2. Okay. And so now I've got 1, 2, 3. Okay. So we can go back to our original setup. And I can fill in my a, b, and c. So now what I want to do is I want to integrate. You know what, actually I'm going to put the constants on the outside this time. So I can integrate like this. So there's my constant for a. Let's see, my constant for b was 3/4. And then my constant for c was minus 1/2. Okay, so now I've got my integrals set up. This time I decided to set them up with all the constants in front, so I set up 3 separate integrals to make that work. So if I integrate, I've got 1/4 times the natural log of x minus 1, 3/4 times the natural log of x plus 1, and then for this last one, so this will actually become plus 1/2 x plus 1 to the negative 1, all of that plus c. And so you can use substitution to figure out any one of those. Okay, so just to end this now with maybe one more example of working with, you know, the different coefficients in case that's throwing you off. I've got this last example here, and so just to remind you, this integral equals what you see here. So I've only got the 2 factors. So if you're feeling a little thrown off with like how to set up the system, I think this is a really great one to just give you a little experience with that. So I strongly recommend you pause the video here, give this a try, and then, you know, spend as much time as you need, hit play when you're ready. Okay, so in this case, so I've only got the 2 factors. So I'm going to have a over x minus 3 and b over x minus 4. I guess I didn't need the parentheses there. Okay, so once again, I multiply this denominator times each fraction. So what am I left with? Well, the top is 2x plus 1, and then I've got a x minus, x minus 4, and b is x minus 3. Okay, so now I've got 2x plus 1 equals, so in this case, there's nothing for me to multiply, right? So I've really just got the x's and the constants. So I've got my x's here, so I'm going to factor out the x's first, and I'm just left with a plus b. And then for my constants, so I've got, here's a constant, here's a constant. So this will become negative 4a minus 3b. Okay, so in this case now, let's see, actually I'll clear a little space. So now when I set up my system, so for my x's, I've got a plus b equals, so remember you reference the left side, this is the term that has the x, so the coefficient on that is 2. So it's going to be a plus b equals 2. And then for my constants, so I have negative 4a minus 3b, that's going to equal 1 because 1 is the constant on the left side. So here's my system in this case. And so now, as far as like how do you solve this, it's kind of up to you. There's a couple ways you could approach it. I'm going to multiply this whole equation by 4. So I get 4a plus 4b equals 8. And then I can use elimination with the second equation. And so then this will give me that I'll have b equals 9. Okay, and then for my next equation, so then I just have to plug that in. So now I can use this a plus b equals 2. So I can say a plus 9 equals 2. So a is going to equal negative 7. So now I can plug all that into my integral. So let's go back to the beginning. And I'll just highlight these. So this was a equals negative 7, b equals 9. Okay, so now I've got negative 7 over x minus 3 plus 9 over x minus 4. So here's what I need to integrate. And so then this will give me negative 7 times the natural log of x minus 3 plus 9 times the natural log of x minus 4, all of that plus c. Okay, and so that brings us to the end of this example video. So if you found that helpful, please consider hitting the like button or subscribing to the channel, and I will talk to you guys in the next video.